All right, let's talk about something that is a total game changer for any PLC programmer: markers. You might also hear them called memory bits. They seem super simple on the surface, but I'm telling you, getting a handle on them is one of the biggest secrets to writing code that's clean, efficient, and, actually professional.
Okay, so here's our game plan. We're going to start with the basics. What even is a marker? Then we'll look at a really common and kind of messy problem they're designed to solve. After that, we'll see the elegant solution in action. And we'll wrap up with why this isn't just a neat trick, but a critical skill you've got to have. So, first things first, what is this thing we call a marker or a memory bit? Let's break it down. So you've got to understand this key difference. On one side, you have your physical outputs. We're talking real, tangible hardware that controls motors, lights, valves, stuff you can actually see and touch. But on the other side, you've got markers. These are completely virtual. They're software-only switches that don't exist in the real world at all. They live exclusively inside the PLC's memory just to help us organize our logic. The best way to think about a marker is like a digital sticky note. Your PLC can look at a whole bunch of different conditions, and if they're all met, it just flips this internal bit to on. It's like putting a little check mark on that sticky note. Then, later on, other parts of your program can just glance at that one sticky note instead of having to go back and recheck all those original complicated conditions.
So why should you even care about these virtual bits? Well, it all comes down to a super common problem. A trap, really, that almost every new programmer falls into at some point.
Let's set up a scenario here. Let's say you have 3 different outputs you need to control: a motor, a warning light, and some kind of alarm. And the rule is simple. All 3 of them should only ever turn on when the exact same 3 conditions are all true at the same time. Okay, so for the motor, it's pretty straightforward, right? You build your ladder logic, you check for condition A, then condition B, then condition C, and if they're all good, boom, you turn on the motor. Easy enough. But then you get to the light. So what do? Well, you do the exact same thing all over again. You check condition A, condition B, and condition C again, just to turn on the light. You're already copying and pasting code. See where this is going? And yep, here we go again for the alarm. The same 3 conditions, copied for a 3rd time, just to fire off that alarm output. You can already see how this is getting bloated and messy and fast. And this is where things get really painful. I mean, think about it. What happens if your boss comes over and says you need to add or maybe change one of those conditions? Now you have to go on this scavenger hunt through your program, find every single place you repeated that logic, and pray you edit each one perfectly. It's inefficient, and it's just asking for bugs. So yeah, there has to be a smarter way to do this.
So let's get to the good part, the solution. This is where things get way cleaner, way more professional. And this is where our little virtual marker becomes the hero of our story.
The whole philosophy here is super simple, but it's incredibly powerful. Stop repeating yourself. Do the hard work of evaluating your complex conditions just one time. Store that simple true or false result in a marker, and then just use that simple marker as your trigger for everything else.
Now, let's actually see this in action. We're going to rebuild that same program, but this time with a marker. And trust me, the difference is going to be night and day.
So here's the new game plan. In your very first network of code, you check your conditions A, B, and C. But instead of turning on a motor, you just flip on your internal marker. Let's call it M0.0. And from there, it's ridiculously easy. For the motor, you just check if M0.0 is on. For the light, just check if M0.0 is on. For the alarm, you guessed it, just check M0.0.
And this right here just lays it all out, doesn't it? I mean, look at the before column. It's just a mess of repeated logic. It's clumsy. But on the right, the after, it's so clean, it's modular, you can understand what's happening in about 2 seconds. The main logic is handled in one single spot, and everything else just follows its lead.
Okay, so we've tidied up the code. Big deal, right? Well, yeah, it's a huge deal. Let's talk about why this matters on a practical, real-world, day-to-day level for you as a programmer. This right here is the #1 reason. Seriously, if a change request comes in, and it always does, and they say, hey, we need to add a new condition D, you don't panic. You just go to that one single network where your marker gets set, you add condition D, and you're done. The entire program is updated instantly and reliably.
And really, all these benefits just stack on top of each other. Your code is cleaner, which means debugging is way faster. It's easier to modify, which means your programs are more scalable. And a lot of the time, this kind of streamlined logic is actually more efficient for the PLC to run. It is a win on every single level.
So, look, getting the hang of a simple tool like a marker, it's not just about this one little trick. It's about learning a fundamental way of thinking that makes you a better programmer. Markers are really just the beginning, the tip of the iceberg. Every PLC has a whole toolbox full of internal memory for timers, for counters, and all sorts of specialized functions, all designed to make your code more powerful. The real question is, which one are you going to explore next?